I began by talking about some of the general principles you need to bear in mind as you're beginning to deploy a secure Linux system. Now I'm going to start talking about some of the mechanics of it. For example, integrity verification. If you are if you want to be really certain that as you're installing your operating system, whichever one that is, one of the things you need to do is make sure that the file you have is intact, that it has not been either maliciously or accidentally modified or compromised while it was in transit from point A to point B. Whether that was downloading it off an FTP server somewhere or a torrent site, or even if you've successfully copied an ISO image from one storage medium to another. You can do this with checksum verification. In general terms, integrity verification. If you're following along in the book, we start on page 15. The book only talks about using MD5 sum. Our lab also talks about how to do the same sort of thing with the GTK hash program inside Linux. So this box over here, so this whole thing is Debian. The background, this is Debian 9. And as you can see, it's got multiple volumes. It looks like you actually have a disk of the Debian 900 ISO mounted into a disk drive. This is the XCFE image. Now this thing over here, this thing that's in VirtualBox, that's actually Ubuntu. This thing over here was probably also Debian. In any case, you can either use the MD5 command to you feed it MD5 and then the target file, and that generates an MD5 hash. For lack of a better term, it's a fingerprint. And if anything at all changes about that file, that hash value will change. This is something we played with ourselves in the lab. You make a text file, you put some text in it, a quote, even a single sentence, and then you go back, you hash that out with either MD5 or GTK. And you'll notice with the GTK hash program, it's of course a GUI program, and it also generates multiple hashes, MD5, the SHA-1 hash algorithm, and the SHA-256. Obviously, they're all different. The thing about hashing is that it takes a variable length output and a variable length input and generates a fixed length output. So whether you're talking about a file that is 1K or a meg or a gigabyte or whatnot, it'll generate the same length of hash. We can also use this thing for HMAC. HMAC stands for Hashed Message Authentication Code, HMAC. You can use this to verify the integrity of a message, say for example an email, as it's passing down the line. So we can do this. We want to make sure that our ISOs are intact. So for example, if you've got an ISO that just is not working for you, it seems to be okay and it never quite works, run it. Maybe something has gone subtly wrong with it. Another thing we can do, disk encryption. The book talks about LUKS, LUKS. This part starts on page 17. You can use this for disk encryption. You're going to install it. You're going to decide which partitions need encryption. You're going to specify the header. You're going to mount it again. Now the thing to note here is that once the disk has been encrypted, you need this program to mount it at all. So if you install this program, encrypt your disks, uninstall it again, you've just lost access to your data. So don't do that. Network scanning is another fun one. This is actually another one that I've demoed already. Nmap is an extremely useful tool. We've done everything from SYN scans to stealth scans, to operating system scans, to port scans. You need to get good and familiar with how Nmap works. I saw a lot in the Sec Plus, a significant information in the Sec Plus study material about Nmap, and knowing exactly which of these flags do what. This is also something I've demoed. You can use it to find all the live hosts on a network. Say, for example, this one here, nmap-sn, and then you give it a network range, 192.168.0.0/24. That means it's going to scan the entire 192.168.0.0 through 192.168.0.254, looking for any and all live systems. And you'll see what you'll see if they're up. You may not see what they are. Honestly, if you can see them at all, it indicates that either they don't have a firewall running, or that firewall is not properly configured. One thing I've learned, if you do this on a Windows network, and all the Windows PCs have their say they're running Windows 7 or Windows 10, and they have their firewall set up, they're practically invisible. You either have to send a much more targeted scan, or you have to go in and do something to that firewall just to see them. This is very, very useful. You'll actually see me using -SV and -SS a lot. The stealth scan. The key difference here between the SYN scan and the stealth scan. You might actually hear the stealth scan referred to as a SYN scan, but really and truly they're two different things. The SYN scan works by trying to establish TCP sessions with the target system on whatever ports it can find open. The thing that this does, it is more likely to leave traces because those sessions are more likely to be logged. The opposite side of that coin is that you don't necessarily need administrative privilege on the system to do that. Say, for example, think about it this way. Do you need admin access to just look at a website? I mean, just any website, ESPN, Google, the Weather Channel. You don't need root access to surf the web. And all those web page connections use TCP sessions. On the other hand, if you're going to bounce a SYN packet off the other end of the line and then not finish the connection, you need a little more access. So your TCP scan actually makes the full three-way handshake. Does the full three-way handshake, creates the full TCP session. It may then not do anything with it, but it does it. Your stealth scan, for example, will send, on the other hand rather, will send a SYN packet at the target and ask and wait for either a SYN ACK or a reset, and then do nothing. So the choice to sort of try to establish the connection and then stop requires more access. Version information is also quite useful, particularly if you're trying to figure out, will this exploit work against that target? And if you've watched my VSFTP demo videos, I tried using an exploit in Metasploitable, which we'll talk about in just a second, against in Kali using Metasploit against my Metasploitable framework VM, my designated punching bag, shall we say. And it worked because that was running VSFTPD 234. On the other hand, I have my services server running on a Debian platform, running web and FTP, also running VSFTPD, but it's running VSFTPD 303. And I bounce the same exploit off that target system and I get nothing, because whatever exploit it's using between 2.3.4 of VSFTPD and 3.0.3, that exploit was patched and closed. So I can exploit the older version of this server, but not the newer one. So you do kind of need to know what you're dealing with. Now you can sometimes guess, just on the basis of the ports that are open and what kind of information you get back, how much information you get back from them, what kind of target you're dealing with. Say, is it a Linux box or a Windows box or whatnot? Or you look at the set of ports you get back and realize, and you can think about, okay, this is running Samba, or this is running Telnet or FTP or SSH or whatnot. But if you really want to know, try to do a service version scan. You can also do an operating system scan. What the operating system scan does is try to fingerprint the target. Now, it's not foolproof, but between the port scan, the service scan, and the OS fingerprint scan, you can get a pretty good idea of what it might be. The other fun thing that the good folks at Nmap are doing is if you create a fingerprint, and say, for example, you set up a target, a specific kind of target, just to see, okay, what does this look like? Say I want to practice getting really good at breaking into Windows 10 Home Premium or something. And so you set up a Windows 10 Home Premium VM, or 5 of them, maybe not all running at the same time. And then you start nmapping it from your Kali or your Parrot or even Fedora's network security toolkit, which is Fedora based, or Debian or Ubuntu, wherever. Fun thing about Nmap is you don't have to have Kali to have Nmap. So you do all that, and you know for a certainty what you did on that other system. You try to fingerprint it, and you get a good guess, shall we say, at what that is. What you can do is you can take that fingerprint and you can submit it to the Nmap people and say, hey, this fingerprint belongs to this server. I know this because I built it, or this client because I know it. I know this because I built it. So let's talk about. I mentioned Nmap. Metasploit. Metasploit framework is, as I've said in class, a PostgreSQL database full of exploits. This is Metasploit 4.11.7. I think we've actually got up to Metasploit 5, so there are more payloads, more vulnerabilities, etc. We're using the free version. I think there's a pro version that's even better. So you can do everything from recon to exploitation. You deliver payloads. You can even exfiltrate data. There is a Metasploitable VM that I've mentioned, designed to be targeted so you can practice against it. This all runs in the console. You basically start up a console. You start up a console session. You start Metasploitable, and then it becomes the console. You can do lots of fun things inside there, change parameters, etc. Change the nature of the attack, etc. So server backups. This is another important thing that we're going to have to figure out how to do. There are a number of different ways to do this. Things like rsync, Amanda, Bacula. Backup and rotation is a key component of this. You want to back up the state of your important servers. You also want to back up key information about what your servers are doing on a day-to-day basis. So there's configuration backup, and there's also log backup. And there's actually a whole chapter in the Linux Plus book about this. Backup policy, rotations. You can do this sort of thing with rsync. No, not with rsync. I meant with cron or the @daemon. If it is important enough for you to log, it is important enough for you to take that log and ship it off-site. It's not good enough to back it up to a separate hard drive on the same computer. You need to put it on a different hard drive, different machine, quite possibly different physical location. Because if all your backups are in the same building and the whole building burns down, you have got nothing. There's a whole section of the security industry dealing with this kind of thing. The folks at Iron Mountain, for example, are really good at this. In the next video, I'm going to talk about chapter 3. Thanks for watching.